Outrace was a little bit like us going to Audi, begging for robots. And then 2 years later, Audi came back to us and said, okay, like let's do a new project. We have this technology called Ultra. And Ultra is so complicating in German that nobody understands it. It's basically, the idea is to do lightweight construction, but to always run the numbers on the materials you use, because many of the lightweight construction materials consume so much energy in production that putting it into a car will not save you enough fuel to actually justify the energy investment of producing the material, building the component, and putting it into the car. In other words, you can build an incredibly light car, complete carbon fiber chassis, blah, 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 but the amount of energy you have to invest into the production of the carbon fiber will exceed by far the energy savings of the car on the road, even if it does like 100, 200, 300, 400,000 kilometers on the road, you won't be able to save enough energy. And then it becomes obviously quite a green painted monster, because it's just a very wasteful product. But the waste doesn't happen on the road. It's not the emission that kills the planet, it's not the vehicle's emission. It's actually the carbon fiber factory that produces the carbon fiber that needs so much energy that the whole system collapses. So basically, Audi Ultra is a sort of set of calculations they run on components where they figure out, should we do this in steel, aluminum, carbon fiber? Because steel doesn't use much energy in production. To make like 1 kilogram of aluminum, you need 10 times as much energy as for making a kilogram of steel. And carbon fiber is beyond. Carbon fiber is like crazy amounts of energy. So basically, what they do on the racetrack, this is the R18 that won Le Mans in 2010. Audi has this sort of subscription to winning the 24 Hours of Le Mans. They've won the 24 Hours of Le Mans 12 times in the last 13 years. And they always do it with these incredible cars that are basically carbon fiber chassis, but then a lot of components inside that could be carbon fiber are not. They're aluminum castings, they're aluminum extrusions, they're titanium, blah, blah, blah. All different kinds of lightweight materials, always selected for the very, very specific application. So they would never go like, oh, let's do it all in carbon fiber, because it doesn't make sense. And we had the chance for this project to basically take this very, very complex formula and boil it down into something much simpler, which was a chair. And so basically the idea was like, why don't we do a chair? A chair is so much easier to understand. Like all the structural realities of a piece of furniture are infinitely easier to understand than a vehicle that's moving on the street at 360 kilometers per hour. And as we started to work with these guys, we realized that when they developed the cars, they actually put a lot of sensors into the carbon fiber, into the aluminum and into the titanium pieces to understand what happens inside of the material as the vehicle goes around the track. And they really embed little strain gauges. It's little stickers. It's almost you buy them like a Panini sticker album almost, and it's these sort of electronic sensors. They're like 0.0005 millimeter thick, kind of look like an RFID tag, and you just stick them onto a material, and as the material expands or contracts, this little sensor will give you an analog signal, from 0 to 100 to tell you about stretch. And basically what we did the same with our chair, because we felt that using this optimization process of like putting a car on a racetrack, racing it, and then just looking at it and redesigning the whole thing to make it lighter, to make it better. That's how they work. That's what they do all year leading up to Le Mans. They basically build a car, and every time the car's done a couple of laps, they throw it away and they build a new one. And the result will always be a better, lighter, faster, more efficient vehicle. And we basically applied this thinking to the development of a piece of furniture. And using different materials, aluminum for the legs, you don't want carbon for, you don't want a composite there, because composites are very prone to breaking when you hit them, and you know, a chair leg very easily gets impact and stuff like that. So there you use aluminum, it's much more durable. The seat shell, however, is a variety of different carbon fiber layups. So we have micro sandwich in the sort of bottom, which makes it extremely stiff. We have very thin layers of carbon fiber to make the seat surface, which gives it a bit of flexibility as you sit down. And we have rubber carbon composite in the back, which basically makes sections of the back soft. So you can, with composites, you can make pieces that look completely uniform, like a flat piece of carbon fiber, but by doing different things to the layup inside of the material, like the layering of the different carbon fibers and resins, you can make a piece that on one end is completely stiff, extremely hard, you cannot bend it, and on the other end becomes completely flexible and you can bend it like a spring. But from the outside it looks like one slab of carbon fiber. And so we basically made this prototype chair and put something like, I think like 106 sensors into it. In all different locations, like in the legs, you see little sensors, you see all these pressure sensors in the back. And we built this setup in Palazzo Clerici, Via Clerici, in 2012, where we would invite people to sit on this chair, and basically as they were sitting on the chair, as they would sit down on the chair, show them a false color simulation of the forces running through the chair. It's a process called finite elements analysis, and it's basically taking any object you want, splitting it up in 3D voxels, and voxels are something like pixels, just if you imagine an extruded pixel, so it's 1 by 1 by 1, like an additional third dimension. You stack these pixels up, you put load onto them, and then each pixel just changes its color depending on how much stress or strain it receives. So we basically had some almost 2,000 people, 1,600 or something, come to Palazzo Clerici, and everybody was invited to sit down. And as you left the show, you would get a little email with your testing video, a link to your test video, saying thank you for joining this test. And there was another mechanism where we would basically, in a similar way as with Outrace, where we had the messages that people sent pushed back to them as a YouTube video that they would share online afterwards, we would basically give them the result of their test back, which was an augmented reality version of the chair with the finite elements analysis and themselves on the chair.